We are live, Yorick. It's
No,
still
we're
saying
live
are.
now.
We're live now. Okay. Right. Yeah. So our second live stream, Yorick.
Yep, second.
And pretty good time for it because we had an election on the weekend.
Overwhelming majority to Labor.
It was. Oh goodness me. I'm obviously still a rookie here.
Yeah.
So yeah, overwhelming completely, especially with the with Greens getting in as with preferences and stuff like that. So it looks like this battery rebate is a sure thing.
I think it's fair to say it's a sure thing. It still needs to be legislated. So until it's in writing, I think still, we should still be cautious, but it should be a sure thing.
Yeah. And they're not going to have a majority in the Senate, but with the Greens in the Senate as well, it's going to get through really easily, I think.
Yeah, I've got no doubts about it.
So, yeah. Whether that's a good thing for you politically or not, it's a good thing for batteries anyway. It's a good thing if you want a battery rebate, if you want to get affordable batteries. So today I thought it'd be good for us to cover how you get a safe and reliable battery. And so we're going to talk about the things that we do to design your battery to make sure you're getting what you think you want or what you want.
Figuring out what the priority is, yeah.
Yeah, your priorities and a lot of things around the design aspect. Included in that, or the second point is really about off-grid systems. So if you're expecting your system to run off-grid, what does that mean? And is it going to do what you think it's going to do?
Yeah. Well, I think specifically blackout protection.
Yeah, exactly. That's what I mean by off-grid, sorry. Not running permanently off-grid. We don't generally recommend off-grid. We don't do a lot.
We don't install off-grid.
We don't do it because we work in Southeast, and it's not a great idea to, live in Banyo and take your house off-grid, in short. And a big point is safety. And I think we've got a few really interesting points about safety that we want to bring up. Yeah,
we've seen a few battery installs done, not by us, that we've obviously picked up a few things that we thought should have been done better. But we'll definitely go through the main points when it comes to how to design a safe and reliable battery installation.
Yeah, okay. So let's crack into design. So the first question, I guess, when you come to a customer's place, what do you ask them? They go, I want a battery.
Yep. I say, what's the priority? Why do you want a battery and what are we designing it for? Because I think there's three main points we can design a battery to. And that is either we're looking at joining a VPP and trying to basically maximize that functionality.
I'll explain VPP in a second, but go on to your second.
The next thing would be talking about bills. Is it really about trying to have the battery pay for itself as quick as possible? And then lastly, it's all about it'll be backup and how do we design a system, that's focused more towards backup than the other things. So, it's really first things first, what's the priority and what are we designing it towards? And I think the VPP or virtual power plant topic is a really interesting one. I guess it's still fairly early days for that technology as well.
Yeah, so what a virtual power plant basically is that you become a generation station at your house when you've got a battery, because anytime, day or night, you can send power back to the grid. Where normally a solar system, you're producing power at daylight hours where the grid doesn't really need that power. But if you've got a battery and it's between 6 and 9 at night, you can send that back to the grid.
And get paid for it.
That's a really valuable resource to the grid.
Yeah.
And you can get paid a lot for it. And we're talking in the terms of, instead of 30 cents a kilowatt hour, up to $15
up to 15. I mean, look, that's pretty fair and far between. But yeah, essentially, when there is a spike in the wholesale market, the power that you've got in the battery is worth a lot of money, and being able to discharge into the grid and get paid for that at a premium feed-in tariff, because during the day we usually get 5, maybe 8 cents if you're on a high feed-in tariff by today's standards. But being able to dump the power in and get $50 or dollars a kilowatt, like 50 cents or dollars a kilowatt hour, suddenly the maths of having a battery really changes. And I just came from having a consultation with a customer who was wanting to design a battery specifically for that application. Yeah, and so one of the things that I definitely have to look at is, or at least from my experience, having been with part of a VPP, I was an Amber customer for a short while. These power price spikes tend to only last for a very short period of time. And so I think there is really an emphasis on being able to discharge as quick as possible into the grid. So 10 kilowatts in single phase, hopefully up to 30 on 3-phase. And as quickly as you can dump that power into the grid, the more better, or basically the more benefit the grid gets, but also the higher amounts that you can get paid. Because if if you get $5 a kilowatt hour, that's only going to last for maybe 5 minutes or 15 minutes. So, you want to get
exactly. And you've only just started discharging, half a kilowatt of your battery in that time, that's not really going to help you that much, right? So,
Correct. Yeah. So if you can only, if you can dump tens of kilowatt hours into the grid in a very short period of time, then you'll get paid. Let's say you feed 10 kilowatt hours into the grid, and it's $10 a kilowatt hour, which pretty good case scenario. That could be $100, in just that one night by feeding power into the grid at those times.
Yeah, exactly. And okay, can you give us the Tesla Powerwall 3? This is a 2. What does that discharge at?
At 10 kilowatts.
10 kilowatts. BYD is a more complicated situation, right?
Yeah.
Very complicated even with BYD and Fronius's manual. So I've designed a BYD battery sizing guide. If you Google that, you'll come across my blog where I've really simply laid out in a table format, depending on what size battery and inverter you've got.
Yeah, it depends on the size of the inverter and size of the battery as to how much you'll be able to discharge it by.
Yeah. And if you're considering other batteries and VPP is your main point, that's worth considering. But there's something else worth. What if you just get any random battery and you want to go on Amber's VPP?
So not all of them are compatible. And look, we know there are more going to be compatible with, say, Smart Shift. I know there is I think it's Evergen that has another VPP platform which allows you to interlink it. And look, Amber's not the only retailer that's offering virtual power plant style plans, but I mean, that's by far the most, I think, open in terms of, the compatibility, but also as a customer being able to see how much you're being charged and how much you're going to be feeding into the grid for. Sorry, I lost the question.
Well, let's move on to the next one. So I think that's it. So some people want to buy it for VPP. So I think that's a really intelligent idea. If you're buying a battery and you're thinking about a return on investment, then VPPs is a really good. Some people just go, I just want my bill to be reduced.
Yeah.
I don't want to sell my power back for 3 cents a kilowatt hour and then buy power for 30 cents a kilowatt hour. I just want my battery to set me through the night.
Yeah.
So how does that change things?
So I think that there's less of a focus on fast discharge. It's more about being able to offset the nighttime usage. So then we're really looking at, okay, well, what's the smallest battery that we can get away with to get you through the night on an average night? You're not going to get through every night. There's always going to be days where you use more and use less power. But what we do is we look at your historical usage and we look at how much you can charge the battery up by, and then we look at okay, well, what's your average discharge and size the battery according to that. Now, if you're looking at a focus on bills and it's really about that return on investment calculation, realistically, you want the lowest upfront cost, because that's also going to, for the amount of capacity, that should reduce the payback period as well. I mean, look, it's fair to say that we focus more on quality batteries. We're not. They tend to be a little bit more costly, but we see it as more of a long-term investment. And so we're looking at stuff that may take a bit longer to pay for itself, but it's more about 10, 15 years plus. But yeah, definitely when it comes to bills, it's really about maximizing that self-sufficiency.
Yeah, sure. And then there's a third idea, which more and more customers are getting, especially in the southeast after the ex-tropical cyclone hit us.
Yep.
Backup.
Yeah, so backup is interesting because we can talk about either doing full home backup or we can do essential loads. Essential loads is, I think the best option, but I personally like having my whole house backed up, not being restricted. But then, especially if we're talking three-phase, designing the system to be able to cover those essential loads becomes really important, and also the safety design elements. So we'll talk about that a bit later. But that becomes a much more in-depth conversation when we're talking about black start, where the inverter, if you do completely drain the battery, can start up the next day. Making sure that you don't overload the battery. Again, that's another part of off-grid. We'll go into off-grid or at least blackout protection in a bit more detail in a few minutes.
Yeah. Okay. Now, so the question still around the same topic, depending on what is the purpose for you buying a battery. Should we be oversizing or undersizing a battery? And I think this is it's a fairly big one. So all batteries have warranty of throughput hours, right? So what it would actually mean is if you cycle your normally it's a 10-year warranty on your battery, but if you do a full cycle, charge and discharge of your battery every day, or equivalent to, you discharge it half, charge it back up, discharge it half, charge it back up, equivalent to a full cycle of a battery every day, a lot of batteries, you'll run out of that warranty within about 7 or 8 years, right? So technically you can only use sort of 3/4 of it every day on average. You don't use it during the week, you use it heaps on the weekend, whatever you do, right?
Yeah.
So oversizing can be a great idea just for the warranty part to solve, right?
It can be, but then there's also the argument that if you want the battery to pay for itself quickly, cycling that battery harder and really making the most out of the capacity you've got will basically mean that the battery pays for itself quicker. You know, you're working it hard and you're getting the most out of that initial upfront cost, because obviously the batteries are expensive, even with the incentive that's coming in play. Capacity costs, and if you're only draining the battery to 50%, you're paying for basically half of that battery is sitting there idle doing nothing. So unless you're using a VPP to force it to discharge into the grid, again, then you're working it hard and cycling it. So, you know, I think that's a really good question. I personally think oversizing it a little bit makes a lot of sense instead of undersizing it, because, you know, if the rebate, well, once the rebate's in place and you can only do the battery once, I wouldn't buy a battery that you expect to expand later, because you're not going to be eligible for the rebate down the track.
Yes, exactly. That's a good point. Yeah.
But oversizing it as well, you know, it's all within moderation. You know, beyond a certain capacity, it becomes redundant. If you can't export it or you can't use it, you've basically got a battery sitting there wearing through its warranties.
So on that point, though, is if you oversize it, you also can often charge and discharge it faster, depending on the particular setup you've got, right?
Correct.
So if you're able to charge and discharge it faster, that might help you in a blackout when you want your hot water to be running in a blackout. It also will help in a VPP when you want to get all of your power back onto the grid in 15 minutes, like you were mentioning before. So
Correct.
there are a lot of that's a really nuanced topic, right? Which is where you really want to talk to someone about what your objective is.
Well, this is the thing. Yeah, it's about the priorities of the design. But look, I think generally speaking, oversizing it is good, but it has to be done within a budget.
Yes, exactly. Yeah, sure. Yeah. Okay, now we'll really quickly cover, and we've got my document that I've created from different standards here about the locations of where you can put your battery. So the idea around the standards is that batteries can catch on fire, right? With LFP chemistry, we're talking a much lower risk, right?
It is. I mean, look, I think even with NMC chemistry, the risk is really low. You know, these batteries, I mean, LFP is basically what everything is today for home storage. But the reality is that a quality battery, even like a Powerwall 2, they're thermally managed. They've got multiple sensors. You know, they're designed hopefully to fail safe.
Yeah, but regardless, the concept of Australian standards is just to be ultra conservative, which I like that. So because you never know who's installing what on you know, what sort of battery on what sort of house and how they're doing the install quality. Is just that if your battery catches on fire, is it going to burn down your house, and is it going to burn the bedroom that you're sleeping in at night, right?
Yeah. So, you know, in terms of when we're talking and having that discussion with the customer about where we're putting a battery, first things first is most people like to have it outside. Garages are a really good location as well. But then, and again, we're going to talk about more about safety considerations a bit later. But generally what we want is the battery to be out of the sun in a cool location, and ideally away from habitable rooms. So if it's a garage, ideally the house is low set, so you don't have a room directly above. Or if we are putting it outside, you don't want it on a north or western wall. Really, we want it on a south wall with a nice eave. You know, maybe we're looking at putting canopies or some shade screening. It's really about protecting that investment and making sure that you're not going to overheat the battery or potentially void the warranty, installing it in a bad location.
Yeah. And yeah, it's like anything that you put outside. You know, a lot of products now can actually just go on the north face in the full sun, which is a stupid idea, because you're going to, you know, degrade that battery faster. Who cares what the warranty says? You're just going to degrade your battery, and it's going to derate.
That's exactly it.
Exactly right. So, yeah.
So I think the other thing that when we're talking about, you know, design of these batteries, and we're talking about which type of product do you buy, you know, for example, Powerwall 3, or if we're thinking maybe SIG Energy, Anchor, you know, these are all-in-one battery systems where essentially the inverter and the battery are one stack. And that has different design considerations compared to something like, say, Fronius or Sungrow or iStore, where you've got a solar inverter and then the batteries can be installed away from that inverter location.
But even so, you don't want to install your Fronius inverter in the sun either, right? So you want to worry about just longevity of the product, but also derating. When it runs hot, it'll produce less. They throttle the inverter or the battery, so just to protect it, right? So now, talking about fire rating, so if you've got a brick veneer house, or a brick house on the outside, if you put a battery up against the wall, your battery isn't going to burn the brick, so we're fine.
Correct.
But as long as we've got, and so they give us, there's a lot of measurements around this, but generally speaking, 600 mil away from your battery, you need a brick wall. You can't have a window within 600 mil.
Openable window. It's going to be
exactly. Yeah. Yes. Yeah. And let's say you don't have a brick building and you've got, just a timber building or whatever it might be. What do we do there?
So either we find a different location for the battery, which is my preference, or what we do is we look at getting it fire sheeted. So you need a fire rated material that meets a set standard, which I think we've got written there.
Yeah, well, it's just fibro.
It's just fibro. Yeah, fibro.
Yeah, so that's pretty simple, but you have to have a bit of fibro that goes out 600 mil past the battery,
either side,
900 mil above. And if you're too close to the ceiling, you actually have to sheet your ceiling too, which can be really annoying if you've got a really tall stack of BYD batteries, because it's kind of ugly. You're going up into your cornice, and it's pretty tricky for the chippy to do as well.
Why don't we save a lot of the safety stuff for a bit later when we talk about that as a
whole
topic?
Sure. Yeah.
Because I think, when it comes to the design of the system, obviously putting the battery in a location first, which you don't need the fireproofing, is the best option. And then later, obviously fireproofing is, well, if you have to do it, you have to do it, but that adds extra cost, and maybe there's a better spot to put the battery in the first place.
Yeah, okay.
I think ecosystems, Mark, we talk about things being compatible. Like when we did our EV charging video, we were talking about, okay, let's say you got a Tesla Powerwall, you got a Tesla car, you get Tesla Charge on Solar. What's your thoughts in terms of ecosystems?
Yeah, well, I'm an Apple guy, right? And I know some people aren't, but I just like the fact that I can pick up my phone and I can actually copy from my phone and then paste onto my Mac, and it just all works seamlessly, right? That's kind of a nice thing with Apple. But when you're talking about batteries and EV chargers and inverters, you actually want that ecosystem so that you don't have 15 different monitoring platforms that aren't talking to each other, right?
Yeah, I very much agree with that. And look, it can be done. I've got Enphase for my solar, I've got Tesla for my battery, and I've got a Zappi for my EV charger, and I've just managed to make them all work together. But I can tell you that it's a lot easier if it's all the one brand. And I think Fronius does really well here. And I know other manufacturers are trying to do something similar where they've got this sort of ecosystem built in. But I like the Fronius and BYD option, especially when you now have things like the Watt Pilot, Ohm Pilot, Catch. These are all part of that sort of ecosystem that works nicely together.
Yeah. So whichever it is, like if you choose to go SunGrow, I don't know if they can EV charger, but do be thinking about that bigger picture, because a lot of us within the next 5 years are going to have an EV if you don't already. Right?
Well, I think a good example is we were having a chat to BYD about they were bringing out a BYD inverter and battery system to compete, I guess, sort of with the rest of the industry. And one of my first questions is, will it do charge on solar as standard with the chargers that you've got? And they go, no. And I'm like,
they don't have an EV charger.
Well, they do. They have EV chargers, but they're just not smart EV chargers.
They're not integrated with it. Yeah,
no,
right.
And it's absurd. I mean, the thing is, like, anyway, that's where you don't have where there's a lack of an ecosystem that is, I think, a critical part of this conversation. But also having a good ecosystem too, and I think this links back to VPPs, is if you have a charger that can also talk with your battery, your solar system, and you're part of a VPP, well, then maybe what you do is you allow the power company to control somewhat when you charge, so that you get the cheapest rates, or maybe you're not pulling power in from the grid when the prices go through the roof, or when there's likely to be maybe say it's a 40-degree night, and instead of having to be on off-peak circuit where you don't get any charge, maybe you can get them to trickle charge it if there is room in the grid.
Yeah. And on that topic of ecosystem too, you're saying a good ecosystem, and I think we're just talking about reliable, proven products. Because there's that Canberra battery test centre or whatever it was, closed down now, but it was going for like 5 years, where they brought in, I think, around about 22 different batteries or something like that. Brought them in and tested them. And this was at relatively early days. It was started maybe around 2017 of home battery storage. And so many of them failed. In fact, I don't think any of them were perfect, even Tesla and BYD, the earlier model of the BYD, the first version of the Tesla.
Yeah.
Batteries aren't as simple. Every man and his dog's got one, but hardly anyone's got a good one, I would say.
Not to rattle, to pick on SolarEdge again, but I mean, one of our first experiences with batteries and that reliability issue was LG with SolarEdge installations. We did some very early SunGrow installations. I know you did the video of how to actually install the LG battery on the original SunGrow hybrid.
That's right. Yes.
That was almost 8 years ago or something like that.
Yeah.
Pretty early days for home batteries. And I think one of the things we learned very early on and why we didn't jump into batteries head on back in the day was they weren't reliable, and there was a lot of service calls, a lot of that. That we have a whole service team dedicated to the solar side of things, and we would have been spending just as much time or more just reconnecting batteries, when they trip. So I think having waited was a really good idea, and having an integrated product where, like with the Fronis, these are known reliable products. We've had very few issues with the BYDs. We've had very few issues with Tesla. I'm sure we've had a warranty case here or there, but they've been a very stable product.
Yeah, and I was just listening to friends in the industry on the weekend do a video too, and they do Tesla and comparing all their products. And so I guess my point is, do look out for those big name products. And even SunGrow is a big name product with batteries. And they were even admitting just the failure rate is just higher with SunGrow. SunGrow is probably one of the better, it's up there with the top handful. But you've still got a lot more warranty issues with them. So then when you start really going off to your random cheap battery systems, that they're not known, like BYD for being a Goliath in batteries, or, Tesla at being good at everything they do.
And you and I have been discussing this basically since our Shanghai trip, is about what else is out there that competes in terms of reliability that we would trust as a product. And we're going to be talking about that, I'm sure, for months to come. It is a really interesting.
We've been looking pretty hard into Anchor, and what else are we looking
into? A little bit iStore as well.
Yeah, a bit of an iStore or the Huawei inverter. Huawei's a massive company. You can't really go wrong there. So why are you laughing?
Because you want me to plug iStore.
Yeah, exactly. Yes. Well done.
All good. All right. So, look, when we did our last live stream, we got a lot of questions regarding backup. So it was just after the cyclone that we had in Brisbane, and look, we spend a lot of our time educating our customers about how to use their solar and battery system. But a very common question we got was, okay, well, my battery went flat and it didn't continue to charge. And I think, when we start talking about backup capabilities, this is something where, for one, you really want somebody who knows and understands how backup works. And when we talk about backup, this is really essential loads in a blackout, not backing up the house off the battery, or running the house off the battery at night when you're connected to the grid. And that's often there's a bit of confusion as well.
Yeah, there is that confusion. It's that people say to me, okay, if I have a battery, I think I got this question this morning actually down in the showroom. If I have a battery, will it run my hot water system at night?
Yeah.
Yes, it runs everything at night as long as it can discharge fast enough, right?
If the battery's connected to the grid, it should cover everything you're using in the house, or it'll try to cover everything you're using in the house. When you're having a blackout, or if you're off grid, it'll only back up the circuits that are on your essential backup loads. And so when we're talking about backup, it's really those blackout protected circuits.
Yorick, I've logged into the wrong place here. So hopefully you've got the comments up on your screen,
I do.
have you?
I do. Do you want to do a bit of a Q&A now?
But I'll if you read a few, I'll just keep on going about this blackout trial that I was mentioning.
Okay.
As I was trying to do that, you haven't mentioned that yet, have you? So one thing that I would recommend, as soon as you get your battery, or within the next couple of weeks with your new shiny toy, try going out to your switchboard, flicking off your main switch, and seeing what happens. Because when you're in a cyclone, when that happens, you're going to be, you don't want to have to understand, is your hot water system overloading it and tripping it out? If it is, that's the time to call your installer and say, it's not working, what should I do, right? So, for example, quite often we can back up the whole house. That's the simplest and most affordable way to back up a system. And sometimes we do that because the customer asks us to do it. And, the customer is not really wanting to pay the extra money. And they're like, no, don't worry, I'm fine. I'm smart. I know what I'm doing. And then we get a cyclone, the customer's overseas. It's literally happened. And the wife's at home and the hot water system is tripping your system. So learn to understand how to run your system off grid. Maybe just muck around and do it for a weekend to see how long it lasts you.
Yeah.
A sunny weekend to see if you're actually going to get through that cyclone. Know to go and turn off your hot water system if that's not an essential load.
It's also a good party trick when you've got friends over. It's one of the things I like to do. Is occasionally flick off, put my house in off grid, and then you see the lights flicker for, and then you're off grid, and then you can really sort of test it. And I remember actually when I first got my batteries, we were seeing how far we could push the Powerwall 2s. So I've got two, and so I turned one off, and then I basically tried to trip it. So I had the oven on, the induction cooktop, my toaster, I had a space heater running, and I learned very quickly that I really needed to push that hard before I tripped it. But I knew I could find where the limit was.
Yeah. And so exactly do that. Overload your system too. Run your kettle and your oven or something like that. If that's on backup circuits, run it as hard as you can. If you can't trip it, that's good. If you do trip it, at least you maybe know where the limit is. And you also know what's going to happen when it trips. Does it come back on automatically, or do you have to go and jump into your app and reset it? And
if you have trouble, at least you know before you're in a blackout how to restart it. Because if you need to get that advice, it's much better to do it when it's not an emergency situation.
Exactly. Yeah.
Okay, so let's do a quick. Do we want to do a quick Q&A, or should we save that for a bit later?
Yeah. Well, let's grab a couple of questions now. Yeah.
Okay. So. So I did have an interesting one. So from Ryan McCarty, I have two Powerwall 2 Teslas. So I have two Teslas and looking at a Powerwall 3 on three-phase house. How are we with being able to generate export 10 kilowatts on a single phase with dynamic management on three-phase homes in Queensland now? Is that workable?
Okay, so he's got two Tesla Powerwall 2s.
No, I think he's got two Teslas, so I think it's two
EVs.
cars.
Okay,
yeah, but he's got a three-phase house, and he wants to get a Tesla Powerwall 3, which is a single-phase solar battery system.
Yeah. Okay. Yorick, you and I did a video about this. I don't know, when was it? Earlier this year or something, about the BYD versus Tesla. So if you want to look that up, this answers that question. The short answer to that question is, if you're single phase, we don't recommend you using a Tesla Powerwall 3.
Yeah. Possibly if you were going to get three, then, so you had one on each phase, but then again, you'd only have backup on one phase. I'd probably wait for the Powerwall 3 phase if it comes out. There's definitely been talk about it.
Yeah, if you're really set on Powerwall, wait for Powerwall 3, or get 3, like you say. Not the best solution.
No, it's quite an expensive solution.
Yeah.
Look, personally, I'd probably go for just a 3-phase hybrid inverter with batteries, and then maybe just get a Watt Pilot or. I think that's probably the most sensible option. But if you want to be all part of that ecosystem, just hold off a little bit for the 3-phase Tesla Powerwall. Hopefully that comes out soon. We've been waiting for updates, but haven't heard anything for some time.
Yeah. And but Yorick, can we wait? Isn't the sky falling? We've got a short time rebate.
Oh no! Look, it's going to last for 5 years.
Yeah.
I mean, it'll definitely be. You'll get the most rebate between now and January, but also hopefully the cost of the batteries themselves will come down like it happened with solar panels. So obviously, when I started about 10 years ago, we got a lot more of a rebate, but then the price of the panels was significantly higher too.
Yeah.
So, obviously prices have gone up a little bit with time, but they've stayed relative. It's been very inflation-proof solar.
Yeah, and there certainly is a mad rush on batteries at the moment. We came in with so many inquiries about batteries, which is good, and it's fine. If you want to go, it's time to go ahead with the battery now, go ahead. Don't feel the pressure, because the rebate's here and it might disappear. So it's not going anywhere.
It should last until 2030.
Yeah.
So we'll do one more question, and then we might move back onto our main topic of off-grid. So I have a 13.2 kilowatt array and a 5 kilowatt inverter. I plan on getting BYD batteries soon. Should I get an EV charger now, or wait for when I will get the vehicle in a few years' time?
Sorry, can you answer that one? Because I was trying to read another comment.
Easy. Wait until you get the car. There's no point of putting an EV charger in now until you've got the car. Otherwise, you're basically burning through the warranties again. It's not going to make any real difference in cost doing it now. And also, if you don't know what car you're going to get, your charge port will be in a different location. Again, this is a good question that we have a video for. So Mark and I did a whole video about EV charging. So look, we will try and add a few links once it goes, once we're no longer live.
Yeah. Jack Longy Long's online. Hey, mate. Hope you're still there.
Yeah.
Thanks for signing in. Industry legend. Okay, let's talk about backup versus real backup.
Backup versus real.
It's the way that I've written it up on the board.
Yeah. So basically, what we're talking about backup versus real backup. So I guess let's go back to that Powerwall 3 question we just had. So if I have let's say a Powerwall 2, and I've got a 3-phase inverter. Now, 3-phase inverters require all 3 phases to be active for the inverter to turn on. So essentially, if you had, say, a 3-phase Fronius, SAP inverter, and you put in a Powerwall 2, if you were in a blackout, you will only have backup until that battery's flat, because there's no way for that battery to trigger that inverter to kick in. So we're talking, the other way we can sort of think about real backup is black start capability. So now with the Powerwall 3, we can wire panels directly into that Powerwall. And so even if you completely drain the battery overnight, the next morning, if there's enough sun to start supplying the house and start trickle charging the battery, everything will come back online. That's a standard feature with the Fronius inverter too. Actually, I think it's becoming a fair bit more common in the quality battery sphere. So essentially, if you're doing backup in a blackout, make sure you get an inverter that's capable of black start and capable of having the battery charge from the solar in the event of a blackout.
So you explained that 3-phase, single-phase issue, right?
Yeah.
Don't try to have a single-phase hybrid inverter keeping a 3-phase inverter online. Yeah. It's not going to work like that. So there are a lot of rookie mistakes that you see out there, right?
There are, and look, the thing is as well is it's a lot easier to do it's generally a DC coupled battery will do black start much more effectively than an AC coupled battery. So, for example, with my Powerwall 2s and my Enphase system, the way that my Tesla Powerwall 2 will keep my Enphase system running is it essentially tricks the inverters to think that they're connected to the grid. So if I completely drain my battery overnight, then essentially that battery either has to be jump started or it has to have enough reserve in there that the next morning it'll send a AC wave down the backup circuits, which my solar is connected to. And then the solar system then goes, oh, I'm connected to the grid again, powers back up, and hopefully there's enough generation there that it can supply the battery. And so this is where DC coupled systems, which is essentially the norm now, it tends to be a better option.
Yeah. Look, around that, Pravesh, is it, had a question about that he's got a non-hybrid inverter, so just your standard inverter, maybe installed 5 years ago or even recently.
Yep.
So non-hybrid meaning doesn't have a battery charger built into the inverter, to speak roughly. Does he need to swap that out for a hybrid inverter, or can he use it? And we're talking now AC coupling. So this Tesla Powerwall 2, which is basically no longer available, I think, since the Powerwall 3 came out. I don't think we can get stock of it. That is an AC coupled battery, so it doesn't matter what your inverter you have. It's basically like plugging it in with an extension lead to the wall, and it'll just work, right?
Yeah.
So that is one way you can do it. The only option that I would hesitate to recommend, because I don't know it well enough, is the Franklin battery.
So you, from what I understand of the Franklin batteries, even if you have it AC coupled, it won't keep a third-party inverter active. At least not, right? Not with how it's currently set up. So you need a thing called frequency shift control.
Yeah.
So look, Tesla can do this. Fronius can't do it. So that is even though you can AC couple a second Fronius inverter with BYD, it won't keep a third-party inverter active. If anything, it actually knocks it off. So again, when you're AC coupling, you really want a dedicated AC coupled system that can do frequency shift control. And so ones that come to mind are the Franklin battery.
That's what I said.
Oh, Franklin. Sorry, I thought you meant Anchor. So Anchor.
Right, I was thinking Franklin doesn't do that. That's news to me. But okay.
My mistake. Yeah. Franklin definitely can do frequency shift, from what I understand. Anchor AC coupled battery cannot.
Yeah, okay. I didn't know that actually, so that's interesting. Yeah.
Fronius, it does not. So even if you have, say, a second Fronius inverter, only the inverter with the batteries that are connected to it will stay active. But then obviously there's other brands like Synergy which can. So there's pros and cons with all these different setups, and we have our reasons why we sell some brands over others.
I reckon the short answer for that was a very long-winded answer.
Yep.
I would say switch out your inverter.
I agree. If you can switch out the inverter, DC coupled is better. If you've got Enphase, then have a look at some AC coupled options.
Yeah, sure. Okay, so we've sort of covered the design elements of what we would recommend, depending on what you want to achieve out of your system. We've talked about running in a blackout.
Mm.
Now let's get on to safety.
Yeah. So,
Okay.
Mark, if I want to back up my whole house, is there any switchboard work that I need to do?
Yeah, so this is a big one, and I actually was chasing this question from industry friends, from the Electrical Safety Office, from master electricians, about what switchboard work do I need to do. So in your switchboard, you'll have safety switches. They've got that little button that you press and it tests it. We should be doing that every 6 months or something. No one ever does it. But that's what trips in case you touch a live wire. It'll go down to earth, and it's a safety switch for the person, right? They were a type AC breaker, was the most common breaker until sometime last year when the standard set changed and they said you can no longer sell that kind of safety switch in Australia. So if we do a new installation, buy off the shelf, we have to use a type A breaker. Now, type A breaker, just very briefly, is a breaker that it won't get blinded if there is DC current. So if there is some fault, and there's a typical one is when there's train tracks and the DC train tracks, and a DC is going through the ground and you're living right next to a train line, it'll go up and it'll blind the breaker so it won't trip under a fault condition. Now, when we're talking about having EV chargers and DC batteries, and I don't even understand, and there'd be good people in the industry that'll tell me this will never happen, but that your old safety switch can get blinded, and it's good practice to switch that out. Now, it's not only just good practice now, I found out, it's the new 4777 standards that came into effect just recently, say that we have to actually change those breakers out. If we're putting a battery system on there, we have to switch those battery systems out for a type A breaker. Now, that might sound like it's a little bit overkill. And as I've had this argument with people in the industry, inverter manufacturers, and they're saying, Mark, it's never going to happen. And they explained to me in a really complicated way, and they're probably right. It's probably not going to trip. But what if I install your backup system, and then 12 months later, the aircon guy comes around and he goes, okay, flick off the main switch. Of course, they don't read any of the labels we put up there. And they'll go and change your air conditioner, and they get fried, and they work out that 15-year-old safety switch you had in your house is frying them. You're not going to be really impressed with yourself or with me, right? So before we knew it was a rule, we were by default replacing them out with type A breakers. Now it's actually a requirement by Australian standards that we have to change your breakers to type A.
And is that specifically the backup circuits, or is that all circuits?
It's just the backup circuits that we have to. At this stage, you might want to upgrade, depending on how old your breakers are. Hager breakers, which is what we've used for a long time, they've been type A for many years. So if you've got Hagar breakers, you're fine. But basically, you've got an A or an AC on your safety switch to work out if they're the type that are not going to get fooled by an injection of battery voltage, DC voltage on the system.
So not only is it now legislation that all circuits that are on backup have to be Class A RCBOs, it's also just general good safety practice to have an up-to-date switchboard that to the compliance standards.
Yeah, if you're going to spend 20 grand on a battery and you're not willing to spend another grand on updoing your switchboard, that's updoing the safety of your installation. I think you should be considering that, even if it wasn't legislated.
But it doesn't have to be a whole grand. I mean, if it depends on the number of circuits, and if it's an old switchboard or a new one, again, that's part of the quoting process. But that is actually something that a lot of people don't know, and I think we take that very seriously. Safety is first and foremost at MC Electrical, and making sure it's done right.
Yes, exactly. Yeah.
I know we talked a bit about fire sheeting before, and this is another thing that is really important. And look, we have seen some other battery installations that weren't compliant in the fire sheeting, and this is, I think it's really a case where overly cautious is just about the right amount of cautious.
Yes.
So look, I've got my batteries under the house. I did have to fire sheet to be compliant, but I didn't have to put a fire alarm above my battery. That might be overkill, but I think that's for $100 is a cheap safety feature that never hurts. But yeah, as Mark was saying before, essentially when we're looking to find a place for a battery, we need to be away from habitable rooms, openable windows, doorways, but if we are near a habitable room, essentially we need to have fire sheeting 600 mil or 60 centimeters either side of the battery and 90 centimeters above the battery. And also, it depends as well. Like if you've got a, let's say you don't have a habitable room behind the battery, but you've got a habitable room above the battery, you still want that to be fire shielded behind the battery, because if the battery catches on fire and burns out the wall, you want that to not lose that structural integrity. So I'm just trying to find a page here on that, but it was so I think we'll probably put this up later in post, but this is a really interesting one, where we actually talk about essentially if we have less than 900 between the top of the battery and a habitable room above, that whole wall, including above the battery, has to be fire sheeted. And I think this is a thing where we've been talking about the pros and cons of different battery systems. You know, I really like BYD because they don't take up a lot of horizontal wall space, which is often a premium, but they take up a lot of vertical space. So if you do have a habitable room above, a smaller stack can often mean that you don't need to have it fire sheeted. So maybe something like the Fronius Reserva batteries would be better, or the Tesla would be better in that application. So then again, you might, to get the same level of storage, you might need to take up half the wall space in the garage, which if there's shelving, then you lose that shelving space.
And then, the battery might come out too far from the wall. There's all these sort of different pros and cons about that. It is probably far too much for us to cover in a video like this, but there are a lot of, you can't just go, I want my battery there. I'm sure there's a lot of companies that will just put the battery there, but that'll be your problem down the track if it gets inspected, I guess. So
but again, it's finding the right spots for the battery, being away from cars. We'll go into bollards a little bit later. That's one thing a lot of our customers have. Or do we want to talk about bollards now?
Yeah, go on. Talk about bollards.
So if there's a possibility that the car, like a car, could hit the battery, it needs mechanical protection, and I think the standard's 5139 specifically, and so this is often where we get a bit of pushback in the sense that, okay, maybe the garage is the only logical place to put the battery, either because of where the inverter already is, or
out of the weather, out of the sun.
Maybe we don't have a spot, on the south wall we can put the battery, and then we have to put it in the garage. Well, especially if you're losing, say, 20 centimeters or 30 centimeters in the width of the wall, width of the battery, and then you have to have a bollard in front of it. That can eat up a lot of the garage space. And so a common conversation I have is, okay, well, if you were going to open up a car door, whereabouts would you be? Where would that door be so you can avoid, using that usable space? But labels.
Yes, labels are a big one for me. I've spent, it's been my project for this year. I'm not even kidding. Probably February I started.
And you got a laser cutter specifically to do it.
Yeah, so we bought a laser label, that does about a 600 by 900 sheet or something, and we're cutting out all our own labels. Now, I kind of started doing this because, we were spending a fortune on labels, and it was really frustrating because we wanted to tweak our labels all the time. That was just costing us more, and I also wanted to get our own logos on there and make it a little bit better. Bought the laser machine. I started in February reading the standards more thoroughly, and labels are an absolute disaster, as in the labels that you buy off the shelf from your wholesaler are terrible. So here's one example. I won't tell you where I got this from. So this is a sort of label garbage that you have to plaster on top front of your battery. Now you see this all the time. You look on online photos and you'll see garbage like that. They're not exactly the labels, but it's something like that. Plastered all over your battery, big skull and crossbones saying, you're going to die if you install this battery or something. We don't need big labels like that. That's not even weatherproof, so that doesn't help us anyway, especially if you're outside. Some people get a nice plaque and then they plaster all this label graffiti on the plaque, which is a step above, I think, right? To me, and this is just the aesthetic part, this is an example of, instead of all that garbage that I held up, this here we stick on the side of the Tesla Powerwall. So we've made it to fit the size of the Tesla Powerwall. It's got the proper voltage. It's got a QR code, our contact details, and it's got more information and more compliant than all the garbage that labels that people graffiti over top of it. For an example, BYD, that's what we do instead. And if you look at my Fronius inverter there, you'll probably see a lack of labels and you'll think that's non-compliant. Those big ugly labels that people are sticking all over inverters, we've just turned that down to one little label that we put, don't know where I put it now, a little label here that we put on the size. It's completely compliant. We don't need big warning. We don't need 20 font or something like that. It's 5 mil is all we need. Stick it on the side. It doesn't have to be right on the front, making a ugly disaster. It needs to be adjacent. That means on or beside the inverter. So just not making your battery ugly in the first case, I think is pretty important.
The thing that interested me, or I found surprising, was that the labels changed depending on if it was an NMC battery or if it was an LFP battery, and I think it might have been related to if it was stackable or not. Can you?
Yeah, well, that's actually there's a bit more to that debate. So Tesla Powerwall are making us put toxic fumes during fire. Sorry, danger, risk of battery explosion. That's a Tesla one. And that is actually down to the safety data sheet, whether we put that in there or not. It's not really clear from the standards. In reality, it's only a few words there when you do it like that, but you don't have to have big, ugly labels like that. So a lot of this I actually find is just a mess that no one's going to read. No one's going to read how to put their PPE on, when the battery's burning down. So I've got no problem with hiding it away, putting it on the side, making it not graffiti.
Yeah.
There is a big second step to that, though, is that the label guides that we get are just not one size fits all. So see my shutdown procedure on the battery there? We actually don't, if that Fronius and battery system are together, we don't need the shutdown procedure on the inverter. So take one piece of disaster out. They go straight there. And it is telling you to rotate that switch anti-clockwise half a turn, So it's just so much easier for the customer. Turn off the PV array DC isolator. What the heck is a PV array DC isolator if you're not a solar installer, right?
Yep.
Turn off the AC switch. Well, how about you turn off the isolator on the right-hand side of the battery? So just customizing it to your battery so the customer actually knows what to do in the event of a blackout. We've got some more words on that white label that would otherwise be a big ugly label, extra one stuck on there just to be compliant. So it's a balance about being compliant, but also putting words in there that are plain English.
Yeah, I mean, we want customers to understand it. That's the whole point of these labels, is that if somebody needs to access that battery in an emergency, or if they're, they can't call us, they can read it and understand what they need to do.
So yeah, going on with that, these little labels that we put in our breakers. This one is main switch alternative. That is a stupid word. Unfortunately, we have to use that word. So sometimes we just have to stay compliant. Main switch alternative just means that you've got an inverter with a battery connected to it. It's an alternative supply in the case of a blackout. If the grid goes down, there's an alternate supply. I try to keep those stupid words to a minimum that no one understands. Solar Sparkies half the time don't even know why we call it alternative.
Yep.
And like backup supply to main switchboard, that sort of thing. So blackout protection, just talking the switchboard for the Tesla the switch for the Tesla gateway. Just call it a Tesla gateway because people kind of know what a Tesla gateway is, right?
Sure.
So making it, we went to a job a week or two ago, right? I had no idea what to turn off. I had to open the switchboard and check out the wiring to work out how to turn this thing off.
Trying to find the main switch was not an easy
main switch was
feat.
just the first part of it. Yeah, it was
Yeah. Actually, I just thought I might quickly jump back to fire sheeting, and an interesting topic, or just a quick point on that. When it comes to a all-in-one battery, so we're talking SIG Energy, SIG Energy, Anchor, anything where the inverter and battery are one single system, it's essentially you need 900 above that stack. So if the inverter is sitting on top, like let's say this dark section was an inverter, the 900 doesn't start from the top of the battery. It starts from the top of the inverter stack. And so that is also where I think some installers might get it wrong.
Yeah. Right.
And so, I mean, let's just talk SIG very quickly. Let's say you had it's an all-in-one stack, so you have the inverter on the top as standard. And if you had the DC to DC charger, and then the batteries underneath, that very quickly becomes quite a tall stack already. So you just have to be mindful of that. It's from the top of the stack, not the top of the battery modules.
And this kind of does sound a little bit like who cares if you're the customer at home, right? That's an installer's problem. It does become the customer's problem with all these battery rebates. There's bound to be battery inspections.
There should be, yeah.
And if you get knocked back on that, that's just a nightmare. Your installer has to come around and do something that you didn't want in the first place, right? Completely change your system, have patches in your wall and all that kind of thing. So it is important that you're getting an installer that's doing it right, especially when you're inspected. And even though we're jumping hoops sometimes to keep standards that I don't necessarily think are the most important thing, we still have to keep those standards. You know?
It's the law.
By the way, going on labels, Glenn Morris, for those in the industry listening along, did a live stream yesterday on labels for the industry.
Beat us to it.
But I got on there and commented, and so I'm going to do a live stream with him, Toolbox Talk, next Sunday. So if you're interested in the way we're doing labels a little bit more in depth, we'll get onto that on Sunday on Glenn Morris's stream. What's it called? Solar Quip, I think. Yeah.
Yep. Just seeing if there was any other questions that we might wanted to run through.
So everything up there is. Is the battery rebate available off grid? That is a good question, and it's a definite no. And the reason is this is a VPP. It has to be capable of being connected to a VPP. At least that was the early information before passing in legislation.
I've heard mixed information on that. I think it might be, but I'm going to say no. But there's a possibility it could be, but I would be surprised if it is.
Yeah, sure. Yeah. Okay.
The other question I had actually from a customer today was, if I have an existing battery already installed, so let's say you're an existing customer of ours, you've already got your Fronius Simo and your 22 kilowatt hour BYD stack. Can I claim a rebate on the next stack?
From the government? No, you can't.
You can't.
Right? Yeah, it's the first one only. So this is a reason, and that a lot of our customers that were due to be installed in the next month or two, we asked them if they wanted to postpone it, because now that we know we're going to getting a battery rebate, they might decide, instead of putting that 13 kilowatt hour battery on, let's up it to a 15 or a 20 or something like that. Let's go a little bit bigger because we know we're going to get a battery rebate. But if we come back to put another stack on 6 months down the track, no rebate for you for the second time. So.
Yeah, I think that's where going a little bit oversized now makes a lot of sense. I mean, if it is a stackable battery, depending on your budget, go for the bigger stack you can afford, or bigger stack you can do without needing fire sheeting, or whatever your priority is there.
I've got a good question for you, yours.
Yep.
Rudder, if they already have a Gen 24 Fronius inverter, what sort of price are we talking about for a 13 kilowatt hour battery? I've got no ideas of pricing.
Okay.
Give us a ballpark.
Ballpark. Yeah. Okay. So ballpark, I'd be saying for 13, without the battery rebate, around about $14,000 to $15,000.
Okay, and then you're getting around about $4,000 off that, I think. So you're sort of looking around the $10,000 mark.
With a 13 kilowatt hour battery, 13.5 kilowatt hour battery, you should get about $5,000 back.
Yeah, okay.
On that.
So still around the $10,000 markish.
Yeah, around the $10,000 mark after the rebate.
Yeah.
Look, the reason it's a bit of a hard one to answer is it is very much circumstantial. You know, are we doing backup? That adds cost. That's an average price. Are we putting the battery next to the inverter, or do we have to run it halfway across the house because there was, the inverter's in a difficult location? That's really where getting a proper quote, is important.
Mike, thanks for your question about high frequency inverters, but I've got no idea how to answer that, I'm afraid.
Look, I was having a read of that one. I wonder if that relates to off-grid systems.
Yeah, okay.
And I'm sorry, I don't really know.
Or if you're talking about the earlier SMAs or something, yeah.
So, T-class fuses and AC side. Yeah, I'm sorry, I don't know the answer to that one.
Okay, 13.2 kilowatt hour panels on a 10 kilowatt Simo Snap. That was only 3 years old and performing great. You've got a Simo Snap. Of course, it's performing great. What would you recommend there, Yoz? The inverter's perfectly good.
Mm-hmm.
3-phase inverter.
Look,
Gumtree?
look, if you're wanting to add a battery and on 3-phase, I think you change it out for the Simo 12, Gen 24. I think that makes sense. There's not a lot of cost difference.
Gen 24, you said. Yep.
Fronius Simo, Gen 24. Look, you could replace it with a 10 or a 12. I personally think the 12 is worth the extra money. you should get a slightly higher.
Charge and discharge.
No, charge and discharge
it's
is the same.
Okay,
It's the same. Where the advantage is that you can get a bit more power out per phase. So when you have a off grid, you're less likely to trip a whole phase. So that's important. Look, if you needed additional capacity, you could keep the old one and have the second one work in tandem. I was just having this conversation with a customer this morning. If you're wanting to join, say, Amber, Smart Shift only works with one Fronius inverter, so that is a bit of a downside. I think it is very much case by case, but generally what we would be doing now is do a direct replacement of the Simo Snap with the Gen 24 and then wire the BYDs into that.
Yeah. Look, we've got another question that was earlier about how much for a 10 kilowatt system with 6 kilowatts of batteries or something like that. We put indicative pricing of our systems on the website. So if you just go to MC Electrical and what's the link? Pricing or battery prices, solar and battery prices or something like that.
Correct.
We've got a bunch of kind of standard packages and standard pricing there on the website. Yeah.
Okay.
I think we might have even answered it. Well, unless there's more down the bottom. I think
there's more down the bottom. Okay, so from DNR asks, get a Powerball, measure the consumption by process of elimination of all devices and decide what you want to be essential. That's more of a statement than a question. Look, when you're doing backup, in terms of what's essential and what's non-essential, I think essential circuits are lights, kitchen, and maybe the lounge room, main power, things that are less essential, ducted air cons, EV charging for your car, hot water systems. Look, truth be told, most blackouts only last half an hour to a couple of hours at most. If it's multiple days, you really don't want let's say we had another cyclone, you really don't want your hot water system kicking in and completely draining the battery in the early evening and then being without power for the rest of the night. I think if if a hot water system is essential to you, I'd go to either a heat pump or a gas.
Yeah. And I mean, if you really do want all those mod cons and you get blackouts a lot, then just a really big battery system, so that you can actually also heat the hot water. Heat pump, I agree.
Yeah, I think heat pump's essential in that setup. Yeah. Trying to think if there's anything else. But I think, look, maybe one of the key takeaways, go bigger than what you think you need, especially with a rebate. It makes sense to go bigger now than try and add later. Get something that, know what your priorities are and build the battery system for that. If your priority is self-sufficiency and having blackout protection, focus on that. If you're wanting to do VPP and try and milk whatever you can get out of buying low and selling high, I think we designed a system for fast charge and discharge. But really what's, I think, really critical with batteries, and I say this a few times in our videos, is getting a proper consultation, a consultant like myself or one of my colleagues out, do a proper assessment, have that in-depth conversation. It takes time, but at least then you're educated and you should get a system that is going to do what you want it to do.
Yeah. And I want to cover one more point when we're talking about VPPs. Do you want to join a VPP, or do you just want it to cover your power bill? If your point is for a return on investment for a battery, I don't think we're talking no-brainer yet, are we? Like it's not an absolute no-brainer. It can be, right, but it's not necessarily.
It's not necessarily. I think, truthfully, if you're a big power user, it makes more sense than if you're a small power user. So, yeah, that is a real can of worms, and it's very much dependent. And look, just saying that you're going to be part of a VPP doesn't guarantee the battery's going to pay for itself and under the warranty period. The wholesale pricing is quite unpredictable, and it does fluctuate a lot. And look, I know my own experience was less than ideal for what I was hoping, at least based on the prices that I was expecting to pay. But some people find
battery for the
for the VPPs. Yeah. No, look, in terms of, I don't regret getting the battery. I still think that was a great investment. But yeah, when looking at which retailers to use, I think it is really much circumstantial based on your needs and really what level of risk you want to take. Because to be fair, a lot of people really don't like the idea of someone else having control over something that they own. So, I mean, I'm the type of person who really, I can handle it being controlled independently for me, but I much prefer to know what it's going to do and have that, know what I'm going to be paying at what time, and I know that I'm going to have the battery there if I have a blackout.
Yeah. But I think it's fair to say if you're going into buying a battery, don't go, it's like solar, it's going to pay itself off in 3 to 5 years or something like that. This is the best investment. I really need to jump on that $4,000 the government are giving away. You need to go in there with a little bit of common sense. The payback period is going to be longer than that. It's not going to be a really fast payback period. You need to go in there with a little bit of saying, well, there's a little bit of value in me and having blackout protection.
Yep.
And there's just value in the fact that I don't have a power bill for, if it's sized correctly, right?
Yeah.
I don't have a power bill. I don't have to think about that. Maybe I'm going into retirement and I want to, get rid of all my assets or all my cash and put that into assets.
Yeah. I think for people getting close to retirement or people who are out all day, they use very little power. If you're not working from home and all your solar power is basically going to the grid and most of your power is used at night, I think the battery rebate will make the battery make sense financially for you.
Yeah.
But if you work from home and you use like 5 or 10 kilowatt hours at night and you can easily shift a lot of your power during the day, then you're just going to have to face the fact that, that battery might not be as valuable for you as somebody who is retired, who, where they're on a fixed income and they can afford to pay for it up front now. And basically they're doing it to basically reduce their ongoing expenses.
Yeah. And life doesn't always have to be about return on investment.
Correct. So, yeah. I agree with that.
Yeah. So anyway, well, thanks for tuning in, everyone. That's a full hour, is it? Goodness me. Yours, we've got a bunch more. We're checking out a bunch of different batteries at the moment and a lot of other topics that we're going to cover. So keep tuned.
You'll see me in a few more videos coming up.
Yeah.
All right. Thanks, Mark.